Welcome to the lesson on angles. In this lesson, we will discuss the different types of angles, how to classify them, and how we can apply algebra. To start by looking at the definition of an angle, we think about the intersection of two lines or rays. Now, an angle has size, and each angle's size is demonstrated and is measured in degrees. So we're basically looking at the width of that angle, the distance, the width between those two rays of that angle. Now we have four main types of angles. The first angle we'll talk about is a right angle. It is an angle that's equal to 90 degrees. It represents most of the corners, the straight corners that we're used to looking at on most buildings, or at the edges of most floors, or on a square. We also have an acute angle. This angle is less than 90 degrees. It can be as skinny as the one I drew here, or be very, very close to 90, but still end up being less than 90, like this one, which is 89. I have also obtuse angles. An obtuse angle is an angle that is larger than 90, so it is very wide. The rays are pointing in almost different directions. The last angle we talk about is a straight angle. That's an angle that's exactly 180. This angle appears as a straight line and oftentimes is represented by one at the same time. Now, as we talk about angle pairs, we're talking about how angles relate to one another. The first pair we talk about is complementary, and that's when two angles add up to 90 degrees. They add up to make a right angle. So here I have a right angle, and within that right angle I have two angles, angle A and angle B. Because they are both part of that right angle, they add up to 90. A supplementary pair adds up to 180. So again, I have that straight line, that straight angle, and angle A and angle B, both being on that straight line, add up to 180. They're also called a linear pair. Now with vertical angles, I have two lines that intersect and create four total angles. The ones across from each other are equal to each other. So A would be equal to angle B. Now, as we practice finding angles, it is again important to think about the relationship between the two. So as I try to find the value of B, I look and I see that because they're in a right angle, I know that B plus 51 has to end up equaling 90 because they're complementary. So I subtract 51 from both sides, and I get that B then equals 39. Looking at my next problem, I'm trying to find the value of A. I'm given this diagram where A is across from 165. Well, we know that A and 165 are vertical angles, so A has to be equal to 165. It's not much work to do in that easy example. Now, angles deal with line pairs, and sometimes lines are parallel, and sometimes lines can be perpendicular. With parallel lines, no angles are made because parallel lines never intersect. They never touch. For as long as they'll go on, we'll never see them ever intersect, and they are demonstrated here with the two arrows. Now, perpendicular lines, on the other hand, do intersect, and when they intersect, they create a 90-degree angle, a right angle. Now, oftentimes in geometry, we look at angles and we talk about how we can apply algebra. Now I have two supplementary angles on a line represented by 2x plus 10 and 68, and I know that if I add them up, it'll be equal to 180. So I'll combine like terms on one side and get 2x plus 78 equals 180 still. Then subtract 78 from both sides, so I'll have 2x equals 102. And then as I divide by 2, I can find the value for x as x equals 51. So I applied a rule of geometry to find that value for x. In the next example, I'm given two algebraic expressions opposite from each other on intersecting lines. So I'm looking at vertical angles. That means that 5x minus 18 will be equal to 2x plus 18. So now I combine like terms across the equal sign. I'll bring the 2x to the other side and have 3x minus 18 equal to 18. I'll add 18 to both sides, and I'm left with 3x equals 36. Dividing both sides by 3, I get x equals 12. So again, apply the rule of geometry, and I can find the value of x. The connections to angles are very important, as angles and lines make up all the basics of landscaping, architecture, even art, and photography.